So what if you're in your chemistry class or you're in a lab somewhere and someone asks you to get 4 moles of lithium from the storage room? Well, how would you know what 4 moles of lithium were? Well, you could say that you need to get 2.4 times 10 to the 24th atoms of lithium, and that's just 4 times Avogadro's number. But how are you going to count those atoms? Moles, although useful for figuring out how much of a substance you have and comparing one substance to another, is not the best thing to use if you are trying to figure out how much of something that you need. For that, we have to convert our moles into an easier unit to measure, such as grams. Well, how do we do this? We're going to use a method known as stoichiometry. This is also known as dimensional analysis. And this is a technique that if you learn how to do it now, it's going to allow you to solve all sorts of problems that involve conversion from one unit to another. For example, let's say that some event occurs in 2,135 minutes. Well, that's a big number, but how will we get a better sense of what this is? Well, we might want to convert it to hours. So we have to convert this number to hours, and maybe that will give us a better sense of how long a period of time this is. So when I do stoichiometry, there are several steps that we're going to do. First, we will take our given. So whatever number along with the unit that's given in the problem is known as our given. So we'll take our given and we're going to put it over the number 1 as a fraction. So 2,135 minutes over 1. I'm then going to multiply by a new fraction, and I'm going to, on the bottom of the fraction, I'm going to put the old unit. So here is minutes. That's what we consider the old unit. So I'm going to put minutes on the bottom. And on the top of our fraction, I'm going to put what we want to get to, which in this case is hours. Well, why do we do this? Well, it turns out that just like numbers, for example, if I had 5 divided by 5, that cancels to give you 1. The same thing can be said of units. So in this case, I have minutes over minutes, and the units cancel out. So minutes divided by minutes equals 1, the unit goes away, and we're left with the unit that we want. We're looking for hours. So we know right away that our math is set up correctly because the only unit left when we cancel out units is hours. The next thing is we actually have to plug in units here. And for all fractions, all of these fractions are actually ratios. And they have nothing to do normally with anything else in the problem. They're just things that you can look up or you already know. In this case, we know a relationship. Well, how long is 1 hour? 1 hour is 60 minutes. So this relationship tells me 1 hour is 60 minutes. Notice how I didn't do anything with my first fraction. I can now solve. And remember, when I multiply fractions, I multiply across the top, multiply across the bottom. So I get 2,135 over 60. And that will equal, when I do the division, about 38.6 hours. So this method of dimensional analysis allows me to set up my math so I figured out where my numbers go very, very easily just by saying, well, what's my old unit? What's my new unit? Once I know I end up with just my new unit, then I can do multiplication of fractions and get my answer. And let's see how this method helps us to make sure we're solving a problem correctly. So I'm going to do the exact same problem, but this time I'm going to make a mistake. So I start with 2,135 minutes. That goes over 1. Now if I mess up and put minutes on top and hours on the bottom, let's look if units cancel. Right now we see that minutes times minutes and minutes over hours. There's no canceling out. Here we had minutes divided by minutes, and we can cancel that. Here, if we figure out what our unit is, we end up with minutes squared, that's minutes times minutes, over hours, and this does not equal hours. Right? So this example at the top is incorrect because the unit that we get at the end does not end up being what we want. It ends up being this complicated unit. So we can check units before we even try to plug in numbers. Let's try one more example before we actually do this with chemistry. So in this example, let's say I give you 3,125 seconds. And I want to know how many days that is. How many days is 3,125 seconds? So where do we start? Well, as we said, the first step is to write the given number over 1 as a fraction. So we're going to write the given number, which in this case is 3,125 seconds over 1. And the next step, step number 2, will be to multiply by a new fraction. So we'll draw in this new fraction times new fraction line. Next, we write the old unit on the bottom and the new unit, also the wanted unit, what we're looking for, on the top as the numerator. So in this example, the old unit is seconds, and the new unit that we want to find is days. But we may not know how many seconds are in a day. So instead of converting to days, I'm actually going to convert to minutes. What I can then do is repeat step 3, putting the old unit on the bottom, the new unit on top, and maybe I don't know minutes and days, but I know minutes and hours. And now, again, I can write another fraction. Old unit is now hours. New unit, now I do know hours and days. And I can finally get to the wanted unit. So step 3, you must repeat as necessary. or repeat until the wanted unit is reached. The fourth step is to check that the units cancel correctly. So let's go. This is how we check our work. So we see, well, we have seconds on top of seconds. So if you have the same unit on the top and on the bottom, they cancel. We have minutes over minutes. We have hours over hours. And the only thing that doesn't cancel is days. And that is the unit we are looking for. So we know we are good with how we set up our problem. Once we've done that, we can now plug in numbers for each fraction, or we can think of each fraction as a relationship separately. And what do I mean by separately? Well, we treat each fraction as separate from all the other fractions. So I don't care what numbers came before it, my fractions are going to be the same. So my first fraction, in 1 minute, I know there are 60 seconds. I also know, now we'll go to our second fraction, we have hours and minutes. And I know that in 1 hour there are 60 minutes. Again, I didn't look at any of my other fractions to figure that out. And my last one, days and hours, I know that in 1 day there are 24 hours. I can then multiply across the top, multiply across the bottom, and get the final answer of 0.036 days. And this is my final answer. Again, I make sure that my unit is included. So the last step is multiply the fractions and write in proper final unit.